Welcome to our flip notes here at JYMS on acid deposition. Take a look at this. This is a picture of a major metropolitan area. It's New York City. Here it is on one day. Pretty clear, although the picture is a little foggy, but look at this next day. So you can definitely see that there's a major difference here. And so what we're going to talk about in this flip notes is just what is acid deposition. Now, acid deposition you probably don't hear a lot about, but I'm sure you've heard of the term acid rain. Now, when acid molecules fall from the atmosphere onto land, water, and physical objects, the acid molecules can either be wet or they can be dry. And so when we look at acid deposition, wet deposition is acid rain, snow, sleet, hail, fog, and dew. Where dry deposition is acid molecules that fall from the sky as gases or they're attached to soot and dust. So even though you've heard of the term acid rain quite a bit, acid rain really isn't the best term. Acid deposition is a much better term because you can have acid snow, sleet, hail, fog, and dew. And you can even have dry deposition. So the next time you go outside in the wintertime and you plan on eating some snow, be careful. It might be acid snow. Now, precipitation with a pH of less than 5.0 is what the DNR here in Wisconsin consider to be acid rain. So technically, all rain is going to be acid, and we'll talk about that in just a little bit. But for it to be considered true acid rain, it has to have a pH of less than 5.0. Now, our normal rain is slightly acidic because carbon dioxide dissolves into it. So it has a pH of about 5.5. And if you learned anything about the pH scale, you know anything less than 7 is technically considered to be an acid. But if that was the case, all rain that fell from the sky would be acid rain, and we wouldn't think much about it. So here you can even see that carbon dioxide mixes with rain. And we've done a lab earlier in the year, the carbonic acid lab. Do you remember that lab? So just normal carbon dioxide mixing with rain makes a weak acid, and it has a pH of about 5.5. So that's why we don't consider all rain to be true acid rain. So as this rain falls through the atmosphere, it combines with carbon dioxide and creates a mild carbonic acid. Now, as of the year 2000, the most acidic rainfall in the United States was a pH of about 4.3. Now you may ask, well, what's this year 2000? Don't you have anything more current? I've looked around. It's hard to find things that are more current. So if you watch this video, you can always email me if you can find something more current than that. So what is pH? The pH scale is a scale that measures how acidic or basic a chemical is. And pH means potential of hydrogen. And a pH scale is numbered anywhere from 0 to 14. So not 1 to 14, but 0 to 14. So when we look at this right here, as I'm pointing out, right here in the middle, this is considered to be a neutral. It's not a base, it's not an acid. Anything less than 7 is considered to be an acid, and you've seen some of these. Lemon juice, rain is slightly acidic, baking soda is a base, so anything higher than 7 is considered to be a base. So it's not a typical scale where you have just acids and you have a base scale. It all goes together. Here's another pH scale. Now when we look at this one right here, here we have battery acid, and you know battery acid is bad. Vinegar. Soda is going to be in here in that 3 to 4 range as well, sometimes even lower. Milk is pretty close to neutral. And then you have some of these other harsh chemicals, ammonia, lye, are considered to be strong bases. So again, 7 is considered to be neutral. Now, pH scale is exponential. If you remember, you hopefully remember that from math class. So, in other words, each number change is an increase of 10. So it's not, when you go from a 7 to an 8, it's not 1 time stronger. It's actually 10 times stronger. So a pH scale is exponential, meaning that a pH of 4 is 10 times more acidic than a pH of 5, and 100 times more acidic than a pH of 6. A pH of 9 is 10 times more basic than a pH of 8, and so on. So you get the gist of that. Now, what do we know about acids? An acid is an electrolyte that releases hydrogen ions, H+ ions, into a solution. Some common acids that we have. Well, we all have acids right now. It's in our stomach. It's called hydrochloric acid, and this is your stomach acid. Sulfuric acid, H2SO4, is what we find in batteries. Nitric acid, HNO3, is found in fertilizers. Carbonic acid, H2CO3, we find in cave formations, or it's what creates the caves. And we created that earlier in the year. And the ones with asterisks come from fossil fuels. A lot of times we're going to refer to sulfuric and nitric acid as your SOXs and your NOXs, your sulfur oxides and your nitrogen oxides. So what are some properties of acids? One, they tend to taste sour. And I wouldn't recommend going out and tasting, a battery to see if it tastes sour. That wouldn't be a wise thing to do, but they tend to taste sour. They destroy proteins. They corrode metals. They dissolve other chemicals. And they conduct the electricity. And if we were going to test for an acid, one of the things we might use is litmus paper. And it would turn blue litmus paper pink. And that's what we actually use in the beginning of the year to check for carbonic acid. Now, bases are the opposite. A base is an electrolyte that releases an hydroxide ion in solution, an OH negative. Some examples are lye, which you find in drain cleaners, soap. Aluminum hydroxide you find in deodorant. And ammonia, which you find in cleaners. Some of these things are kind of interesting. You see that lye is found in soaps. And it's not that strong, but in the old days, a bar of soap was pretty nasty. If you couldn't use it every single day, otherwise your skin would not be able to handle it. So what are some properties of bases? One, they tend to taste bitter. They feel slippery. They may cause burns. They conduct electricity. They turn red litmus paper blue. So it's the opposite. You can have red litmus paper and you can have blue litmus paper. And it's a great way to check for a base. Now, neutralization. When we look at neutralization, a good term for neutralization is being able to neutralize. It's when you have something strong of one and you have something strong of another, you put them together, it's going to be neutral. So equal strengths, acids and bases cause or can neutralize each other. And this neutralization actually forms a salt. So there is a byproduct of this neutralization. And a salt is defined as a metal combined with a nonmetal, such as sodium chloride, potassium chloride. And that is the end of part 1. So hopefully you've enjoyed.